Okay, I don't have this written down, but this is section 3.4, the equation of a line. And we've already talked about slopes, and you kind of know how to work the y-intercept in there. It's for slope-intercept form. So this is section 3.4 in your book, and we're off and running here. Kind of a neat picture, but just kind of a quick reminder how our equations work. Closer to 0 you are with a slope, the flatter the line is going to be. And of course, the larger the number is for your slope, the steeper it's going to be. 3 types of equations. Our favorite type is slope-intercept form. Okay? And of course, that looks like y equals mx plus b. Okay, you can do y equals b plus mx, but we generally write it mx plus b. Another type would be that standard form. And that looks like ax plus by equals c. Okay, and you cannot look at that and tell me what the slope is. So if you see 4x plus 8y equals 2, do not tell me the slope is 4. It's not in slope-intercept form. So you can't look at standard form and say, hey, there's a slope. It's not that way. You have to actually put it into slope-intercept form in order to figure it out. And then the third form is called point-slope form. Okay, whoa. Did we not spend like 2 months, it seems like, doing this in Algebra 1, and now we're covering it in like 2 days, practically. This is what it looks like. Y minus y sub 1 equals m, that's your slope, and then x minus x sub 1. Okay, so if you didn't quite get it learned in Algebra 1, you got to get it together right here in geometry. That is point-slope form. Okay, so most of the time when you write it out, you're going to have something like y minus 2 equals, maybe you have a slope of -3 and then x minus 4. Okay, I do want to point out that this y, oh my goodness, that is not supposed to be what I was doing there. I wanted to highlight that y. Okay, so if we have this y and this x will always just stay y and x. Okay, unless we're trying to manipulate something in the equation. All right, moving on. Example 1, write an equation in slope-intercept form. Slope-intercept form of a line with a slope of 6 and a y-intercept of -3. Okay, so my slope is 6, and my y-intercept is -3. So I will keep the x and then write plus -3, or you can write -3. Either one will be fine. Example 2, write an equation in slope-intercept form of a line with a slope of -1 and a y-intercept of 4. Okay, also acceptable would be something like -x plus 4. Or you could go y equals 4 minus x. Next. Example 3, write an equation in point-slope form of a line with a slope of -3/5 that contains the point -10, 8. Okay, there's my point. In other words, I have an x, and I have a y, and here's my slope. And let me write that out again for you. Y minus y sub 1, m, x minus x sub 1. So basically, I'm substituting in here, here, and here. So I should say this is my first point that I'm going to choose from. So y minus 8 equals the slope, which is -3/5, and then x, and then minus -10. I'm going to try to catch that right now. Minus negative would be the same as plus. That way I don't have to write out this whole equation all over again. All right, so y minus 8 equals -3/5 times the quantity x plus 10. And that is your point-slope form. Write an equation in point-slope form of the line whose slope is 1/3 and contains the point 6, -3. Okay, so I'm going to go y minus y1 is -3, so minus negative, instead of doing that I'm going to do plus, equals the slope, which is 1/3, and then x minus my x value is 6. Da, 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 da. Point slope form. Example 5. Write an equation in slope-intercept form for a line containing 4, 9 and -2, 0. So if I want to go slope-intercept form, I don't have the slope. I don't have the y-intercept either. Oh my goodness. Hey, this is where point slope form can come in handy because I actually have a point. And in fact, I have this point, or you can pick this point, whichever one you like better you can pick. The only thing I would still need is points, if it's going to be a point, the slope form, then I still need the slope. I can find the slope. I have 2 points. Okay, so the first thing I'm going to do is find the slope. Okay, you can go 0 minus 9 over -2 minus 4. -9 over -6, which is 9/6, but of course you know in Mrs. Talley's class to always reduce your fractions to 3/2. So I have a slope of 3/2. All right, and now I'm going to write it in point slope form. And I can pick this point right here, or I can pick this point right here. I like this one because of the 0. Some of you might not like it because of the negative and you can go the other way. All right, I'm actually going to do it both, just this one time. So I'm going to do y minus 9 equals the slope, which is 3/2, and then you have x minus 4. Some of you may write y minus 0 equals 3/2, and then x plus 2, because minus a negative. All right, and you're like, but Mrs. Talley, the equation or the question asks for slope-intercept form, and these are point slope form. But wait a minute, isn't slope-intercept y equals mx plus b? Yes, it is. So all I have to do is basically solve this for y, okay? So here's one way to do this. I'm going to take 3/2 times everything in the parentheses. I'm distributing. I'm realizing as I'm doing this is not going to be the prettiest problem in the world. 3/2 times 4, top times the top, bottom times the bottom, is 12 over 2. Okay, so I'm going to write out 12 over 2, and then I still have this y minus 9. So really, this is y minus 9 equals 3/2 x plus, or not plus, silly Mrs. Talley, minus 6. Okay? It's still not in slope-intercept form until I add 9 to both sides. Okay, now I'm writing at the bottom, but I've got y equals 3/2 x plus 3. Okay, if you went the other direction and you pick the other points, you're like, but it will come out the same. It's different. Well, let's work it out. Y minus 0 equals 3/2 x. 3/2 times 2, top times the top, bottom times the bottom, bottom times the is going to be 6 over 2. So I have y, I don't even have to write minus 0, equals 3/2 x plus 3. Whoa! Same thing. Slope-intercept form, and it contains this point and this point, and I have my slope. We're good to go. Example 6. Write an equation in slope-intercept form again. I'm going to do another one just because I think that a lot of you need to see that again. There was a lot of review and a lot of putting this all together. I've got 2 points. With 2 points, I can find a slope. I'm going to do slope the other way now this time. 3, 2, and 6, 8. To get from 2 to 8, I have to add 6. To get from 3 to 6, I have to add 3. So my slope is 6 over 3, but we all know that's going to be the same as 2. All right, I'm going to write it in point slope form. Okay, and I'm just going to pick one. I'm going to go with the smaller numbers. So y minus the y value, which is 2. The slope is 2. Then I have x minus 3. The question is write the equation in slope-intercept form. So now I'm going to solve for y. So I'm going to take y minus 2 is equal to 2x minus 6. Now I'm going to add 2 to both sides so I get y by itself. So now I have y equals 2x minus 4. That's an equation in slope-intercept form. Okay, moving along. Write an equation in slope-intercept form for a line containing 1, 7 that's perpendicular to the line, and I'm sorry that's kind of jumbled here, y equals negative 1/2 x plus 1. So if my slope right now is negative 1/2, my perpendicular slope will be opposite, which will be positive, and the reciprocal of 1/2 is 2. So basically I need to use this as my slope, and I have a point. I've got a point and a slope, so this is where I use point slope form. So y minus the y value is 7, getting that from here, and then the slope is 2, and then x minus my x value is 1. Okie dokie. The question says I need to get it in slope-intercept form. So here I go again. Slope-intercept form, here I come. Y minus 7 is equal to 2x minus 2. Now I'm going to add 7 to both sides. So this is gone. I have y equals 2x plus 5. And there you have your solution to this. Example 8, write an equation in slope-intercept form for a line containing negative 3, 4, and is parallel to this equation, or the line 3/5 x minus 4. So if it's parallel, then I have to have the exact same slope. I have to have the slope of 3/5, and I'm going to go to point slope form again. And I'm going to use this as my x and y value. Y minus 4 is equal to slope, which is 3/5. X minus, minus negative 3 is going to be plus 3. It is still not in slope-intercept form, but I'm just going to do a little fancy math. I got y minus 4 equals 3/5 x plus, top times the top would be 9, the bottom times the bottom is 5. Okay? Not your favorite point right here, but we're going to add 4. Okay? So this is y equals 3/5 x. I'm going to do math off to the side. 9/5. Isn't 4 the same as 20 over 5? And I do this by taking the denominator times 5, take the numerator times 5, a common denominator, and I'm going to have 29 over 5. Okay? Not the prettiest problem in the world, but that's the answer. That's the last one. We are done with this lesson. I believe this is lesson 3.4 that has now come to an end.